The mapping code I sent you the email. You can take it from there. You have to use square bracket, single quotes. Square bracket, single quotes. Pattern type, there is only one, right? Material, many are there. What are there in material? Chiffon fabric, model. But woolen is not, wool is not there, na? But woolen is not there. Material, right? SILL will be silk. Silk is small letter or S capital letter. Silk. Then MODAL, right? Modal will be fabric type also there, na? Fabric type is also there, right? So what are the things in fabric? Next one is flannel. Wait, anything more? Woolen you have done, na? Flannel, satin and chiffon. Anything more? Okay. Anything else? Pattern type. Huh? Pattern type has only one. Huh? See, whenever variable has space, square bracket, single quotes. Otherwise, dot. Leopard, right? Leopard. Sorry, Leapard. Leopard. Sorry, with Leapard. Huh? Yeah, that's what leopard. We are replacing with the last one only. We are replacing this word with this word. Then we can add it to missing. What is there in decoration? How many are there? Decoration and pattern type have, right? Dot fabric type also. No, right now I'm not interested. Done? So I'm in bicycle share data notebook. So we have completed exploratory data analysis. We have done inferential statistics. We have also worked upon data pre-processing. Now we can enter into the process of the model building or the machine learning concepts. EDA is done. Inferential statistics is done. Data pre-processing is done. Now these are continuation processes. As and when we do work on new data, we will work on new EDA methods, new pre-processing methods, and all will be learned as we look at different data. It's a continuation process. See, hypothesis testing first to be done if missing values are limited and if they are not in critical variables. Before doing, then what we do is, after doing get dummies also, you create a new data frame. Again, we have to create a new data frame, not the get dummies one, new one. Get dummies one we will use for machine learning. We will create a new data frame where we have the actual levels and the actual data, and then we'll do the hypothesis testing. That scenario we will also explore. That also we will do. All right. Within machine learning, there are two types of learning. Supervised learning. We have to change the connector. Supervised learning. We have complete understanding of data, like understand variables, variable distributions, know dependent variable, and also know or algorithms. So in supervised learning, we will have complete understanding of the data. We have understanding of variables. We understand the distributions of the variables. We also know what is dependent variable, and we also know which models or algorithms to be built. Unsupervised learning. No understanding of data, which is dependent variable, algorithms. In unsupervised learning, you don't have any understanding of the, whereas in supervised learning, you have a complete understanding of the data, the variables, the dependent variable, and also which models to build. In unsupervised learning, which is the dependent variable, we don't know which models to run or build. All we can do is we can do a clustering analysis. Supervised learning, we have broadly two set of models, regression models and classification or regression algorithms or classification algorithms. Dependent variable, numerical, continuous, closer to normal distribution, outliers, missing values. Then regression models or dependent variable is non-numerical, multinomial levels or classes. Then classification algorithms. So the structure of the dependent variable will tell you which type of models to be used. Should I use a regression model or should I use a classification model? It depends on the structure of the dependent variable. If the dependent variable is numerical, continuous, closer to normal distribution with minimum outliers and no missing values, regression models or algorithms are. If dependent variable y is non-numerical, either binary means two levels, yes or no, or multinomial. Multinomial means more than two. Then classification algorithms must be. So the dependent variable will decide whether you should use a regression algorithm or you should use a classification algorithm. Okay, shall we move forward? Now, let us understand the regression. Supervised learning regression models or algorithms. The primary algorithm is multiple. The primary algorithm in regression algorithms is multiple linear regression. Multiple linear regression explains the linear relationship between a dependent variable and multiple independent denoted by X. Multiple linear regression explains the linear relationship between a single dependent variable Y and multiple independent variables. What is linear relationship? Straight line relationship. Linear relationship is straight line relationship. Linear relationship, multiple linear regression is an equation. The multiple linear regression is an equation, and this equation is used the values. The equation is used for predicting the values. What is the equation? Y is equal to B0 plus B1, or let me use the right ones, beta 0, beta 1 x1 plus beta 2 x2 plus beta 3 x3 beta n xn, the error term. Y is equal to beta 0 plus beta 1 x1, beta 2 x2, beta 3 x3 till beta n xn plus et. Now let us understand each of the components. Y is beta 0 is intercept. What is an intercept? The point at which straight line touches which axis? Y axis. The point at which the straight line touches the Y axis or breaches the Y axis, we call it as intercept, also called as constant. Beta 4 till beta n, we call them as coefficients. X1, x2, x3, x4, xn, we call them as independent. Et is called error term or residual. The formula is y minus y hat. So these are the components of the equation. The output of a multiple linear regression algorithm is an equation. Once we get the equation, we will use it for predictions. Now, if you look at the regression equation, what data we have? We have the data of y. We have the data of x1, x2, x3. What we don't have is the coefficients and the intercept. We have the independent variables, we have the dependent variable. What we don't have is the coefficients and intercept. The matrix formulation of multiple linear regression for solving intercept and coefficients is equal to X transpose multiplied by X inverse matrix multiplied by X transpose multiplied by the matrix formulation of linear regression is, I'll show you the matrix formulation. X transpose multiplied by X to the inverse matrix multiplied by X transpose multiplied by Y. By solving this matrix calculation, you will get the intercept and the, once you get the intercept and the coefficients, we will create the equation. Once you get the intercept and the coefficients, we will create the equation and we will use that equation for prediction. X transpose multiplied by X to the inverse matrix multiplied by X transpose multiplied by Y. This is the matrix formulation of multiple linear. So if you want to write a program for multiple linear regression, you have to program this formula. You have to write the program for this, where X is the independent variables, Y is the dependent variable. Multiple linear regression is a parametric algorithm. Parametric algorithm means there will be prior and post. Non-parametric algorithm will not have any assumption. Non-parametric algorithms will not have any assumption. Parametric algorithms will have both prior, that means before building the model, and post, after building the model. Prior means before building the model, whether those assumptions are satisfied or not. Post building the model, whether the model is good or bad, based on the post model assumptions. The following are the assumptions. The first assumption is Y must be numeric, closer to normal distribution, and no missing values. Y is your dependent. Please remember this, there is only one dependent variable. The second assumption, X's or independent variables can be both numerical, independent variables can be both numerical and non-numerical, but dependent variable can only be numerical. Dependent variable can only be, there must be a logical relationship, there must be a logical linear relationship between the dependent variable and independent. There has to be some logical relationship. India's GDP is dependent on India's inflation, India's exports, India's imports, India's what you call national income. All these things will impact the GDP of India. Will Pakistan GDP affect India's GDP? No, right? So you should only consider those variables which have a direct relationship or a logical relationship. A logical relationship has to be there. Now, will America GDP affect Indian GDP? Yes, because we export services to US, right? If US is slowing down, that means Indian IT companies will have less. That means it will affect our GDP. Consumption will be affected, GDP, which is happening now. So many layoffs are happening. If you see the last 15 days, all the companies are giving their 3-month earning reports, right? Two-wheeler sales have fallen down, car sales have fallen down. Everything has, even biscuits, FMCG companies are also saying their sales have come down. Why their sales are coming down? Because since November or since middle of October, layoffs have started. Why layoffs are happening? Because US and Europe is not doing. Because of that, purchases all will come down, right? Two-wheelers, four-wheelers, houses, everything will come down. So there is a logical relationship between US and India. But there is a relationship between India and Pakistan? No. So you have to have that logical understanding. Only variables which you have a logical relationship should be included in the model. All those unnecessary variables you should. Will PIN code affect the loan approval of a person or not? PIN code is nothing but location. So how does location affect the approval? Because whether it is a rural, urban, within urban also. Within urban, neighborhoods are classified. Within urban also, middle class neighborhoods are there, upper income neighborhoods are there, and bastis or lower income neighborhoods are. Now, if you are applying from a lower income bastis or neighborhoods, your loan approval rate will be. If you are applying for a middle class or an upper middle class neighborhoods, your loan approval rates will be high. If you are applying from higher income neighborhoods, also. So how will the algorithms require? Based on the PIN codes. That is, if you look at the mobile loan applications, they ask for PIN code because the backend data is put based on the PIN code classification. PIN codes are classified. No multi-collinearity. Independent multi-collinearity. A very strong, typically greater than 0.95. See, some textbooks say greater than 0.90 also. But my practical experience is greater than 0.95. Very strong correlation between which will lead to overfitting problem. If multicollinearity is found, do not include both variables, one among. If multicollinearity is found, you should not include both the variables. You should choose one among them. Remember, correlation is bivariate statistic. It will be calculated on combination of two variables. Output will be a matrix, but it is between two variables only. So if two variables have very strong correlation, you should drop one of them. Which one you will drop? Your logical thinking and domain knowledge. If one of the variable is dependent variable, do not drop dependent variable. Drop the other. You have to drop the other variable. Never drop the independent variable, dependent variable, because dependent variable must be there, right? So that logical thinking you need to have. So multicollinearity. How do you find multicollinearity? Correlation analysis. Now in interviews there is also they're asking there is an other metric for multicollinearity is VIF. Inflation is greater than 2. Collinearity. Just let me check the VIF one more time. Yeah, whereas inflation factor. Whereas in variance inflation factor is also there. That is another method of finding multicollinearity, but it is in statistical softwares. We don't get it in machine learning softwares. In machine learning softwares, we will look at correlation. Remember, multicollinearity greater than 0.95 correlation between two independent variables or dependent and independent variable. If it exists, you have to choose only one variable. Otherwise, overfitting will happen. I'll tell you in a minute what is overfitting. Exogeneity. Dependent variable is dependent on independent variables, which means Y is dependent on Y. Only variables is significant on the dependent variable must only be included in the model. All variables must not be included. Variable selection must be done. Variable selection. Take for example, approval of loan. Bank collects on every customer close to 200 to 300 variables of data. But do we need all those 200 variables to approve a loan? We might need some 10 to 12 variables, preferably less than 10. Banks now are using less than 10 only. We need only 10 variables to decide whether to approve the loan or not. Or we will build a model with only 10 variables that will decide whether the loan should be approved or not. Building with 200 variables, you can never have a model. It will always fail. But building a model with 10 variables or less than 12 or 12, 15 variables will increase the accuracy of the model, the performance of the model, and the capability of the model to study the trends and patterns will also be very, very. So that is what happens in regression. Generally, people dump all the variables. You need not do that. You can identify the important variables based on your domain knowledge. If you don't have domain knowledge, there are variable selection methods. Nowadays, there are statistically developed variable selection methods using chi-square, hypothesis testing based methods, using what you call Gini entropy in case of decision tree. So there are certain variable selection methods. I will discuss them in detail when we go through that stage where we will talk about automated feature engineering or variable selection methods. But in Python, we have variable selection methods. This was added in the last version of sklearn. In the previous version of sklearn, they have this feature selection. So you have univariate feature selection from select from model, sequential feature selection. Sequential feature selection means first build model with all variables, then delete the last variable, build the model again, second variable from the last, build the model again. We call it as backward elimination. Similarly, you can do forward elimination also. Build a model with first variable only, second model with variable 1 plus variable 2, third model with variable 1, 2, and 3, forward and backward. So that is your sequential feature selection. They are your old days techniques. Old days we used to use that. That will run all the combination of variables and will give you the best fit. Or you can use select from model. See, so in select from model, there are a lot of methods which is using L1 based feature selection. So these are the new ways in which you can select models automatically using algorithm-based feature selection. This is the new version which they have added. Because when you get 400, 500 variables, manually selecting variables will become, we have to use a automated method. These select best methods will help you to do it. In R, we have even more methods. As we go and discuss algorithms, some algorithms also help you to do this. I'll tell you how to find out the variable importance. Based on it, we can select the variable. Sample size. The sample size must be 20 observations. You should have minimum 20 observations per 20 rows per one column. Simply saying 20 rows per one column. Post model based on residuals must be homoscedastic. Residuals must be homoscedastic. In homoscedasticity of residuals is one of the important assumption of linear regression. Homoscedasticity is one of the important assumptions of a homoscedastic model. The residuals will be closely aligned in a narrow range from left to all the residuals are clustered in a close range from left to right. If they're all spread out like a flower bouquet pattern, it becomes heteroscedastic. In regression, homoscedasticity is what we want from the residuals. When you do a scatter plot of the residuals, they should follow the homoscedasticity. The last one is residuals must be normally distributed. Residuals must be normally distributed. QQ plot, quantile plot. QQ plot, quantile plot is what we use to check whether the residuals are normally distributed or. So a QQ plot will look like this. QQ plot normality, if all the residuals, if all the residuals are on the line, the dots are all residuals. If all the residuals are line, normal. If the data is not normal, like this is not normal, right? Skewed. Then you can see the residuals will be away from the. If you look at positive skewness, it will be on top. Negative skewness bottom, positive skewness on. See, this is positive skewness, right? Peak is on the left side. See, all the residuals on top of the line, right? So as many as possible residuals must be on the line. This is a perfect hypothetical situation, but we want as many as possible on the line. As many as possible should be on the Q and Q plots. This will tell you whether your residuals are normally distributed or. One last thing, and then we'll go for a break. The interpretation of output in Python only. Because Python is only machine learning software. It is not a statistical software. R square must be 0.60 till 0.95. Less than 0. Is underfitting and greater than 0.95. R square, the amount of variance in the dependent variable caused by the model or independent. R square is the amount of variance occurring in the dependent variable caused by the model. So the first thing you always check is R square, and it must be between 0.60 to 0.95, in between. If it is less than 0.60, it is underfitting. If it is above 0.95 or fitting, both are problem. You have to rework your variables. What is the concept of R square? The amount of variance occurring in the dependent variable caused by the. Then second one, we get the intercept plus we get the coefficients and intercept to build the. And finally, the diagnostic for all regression models, also called as RMSE. RMSE is equal to square root of mean of the model that has the least RMSE, no fixed range. It is a comparative. There is no fixed range. It is a comparative root mean square error. Square root of mean of residual square. Once again, you can take your break. After that, we will build the model. So I'll explain each of them by calculation. Okay, all of you open that day.excel sheet where we worked on hypothesis testing and all, right? Day.xlx sheet is there, na? Bicycle data. In the day sheet, remove filter on season. Last time we put a filter on seasons. Day.xls. Now copy the variables from temp to CNT. Control C. Copy the variables from temp to CNT into a new sheet. In the day sheet, remove filter on season. Last time we applied a filter on season, remove it, and then copy the data from temp to CNT. So in this case, CNT is the dependent variable. CNT is the dependent variable. CNT means count of bikes rented. Independent variables. Now we have to check for multicollinearity. We have to check for multicollinearity. How do we check for multicollinearity? Correlation analysis. We have to do correlation analysis. Data tab, data analysis. We have correlation, right? In data analysis toolpack. In data tab, you have data analysis toolpack. In the data analysis toolpack, you have correlation. Select the columns from temp to CNT. These are the variables you have to select from the day Excel sheet. All of you got the day Excel sheet, which we're working hypothesis testing and all. Do the correlation. Just select all the variables, labels in first row, new worksheet apply. You will get the correlation matrix. Input range, all variables, including the headers. Then tick mark labels in first row, new worksheet, and you'll get the. Is multicollinearity there? What is the correlation? Yes. What else? No. All complete matrix, look at it. See, input range. Here, all of you look at the projector. Input range for correlation. Select from temp, Control Shift side arrow, Control Shift down arrow. Then tick mark labels in first row. Then new worksheet. Let it be new worksheet only. Select the complete data range from headers. Temp, Control Shift side arrow, Control Shift down arrow. Labels in first row. Tick mark and click OK. Okay. Once you click OK, a new sheet will be with all the metrics. So what is multicollinearity? Correlation greater than 0.95. Correlation greater than 0.95. First you can see here, temp and atemp, yes. CNT and registered. You can see on the projector. And then we have to delete because CNT is what? Our dependent. CNT is our dependent variable. So we will be removing registered from our. Got the correlation matrix, all of you? You got the correlation matrix? So what is multicollinearity? Correlation greater than 0.95. So search for the values which are greater than 0.95. This one, first one, right? Right? Any other values? You can scroll and see all values, nothing except this one, last one, 0.95. So you have to choose between temp and atemp. One variable will include and delete the other variable. You have to choose temp or atemp, first thing. And you also have to delete registered because CNT is our dependent variable. We cannot delete it. So we will delete registered from our. So multicollinearity shows us there is multicollinearity in our data. Correlation analysis highlights multicollinearity in our, right? So the decision we are making is we will keep temp and we will delete registered. We will keep temp, we will delete registered. Go to the data sheet. Click on B column, right click, delete. Click on registered, right click, delete. Control S. Atemp and registered we have deleted. Right click on top, delete. Registered we have to drop. Okay. Atemp and registered. Atemp and registered. Delete variables, columns, atemp and registered. Right click on the alphabet on top. Here, right click on atemp column. So deleted and registered collinearity. Got it? So whenever you do regression model, you have to do correlation analysis. Whenever I give you regression data set, after pre-processing, you have to do correlation analysis only on numeric data. Correlation analysis is done only on numerical variables, not on categorical variables. You have num calls, right? We always separate num calls. On that num calls, you have to do correlation analysis and identify multicollinearity. Write them down. At the end, we will delete those, all of you. So one of the compulsory process before multiple linear regression is correlation analysis. If you have large amount of variables, heat map, SNS.heatmap, SNS.heatmap, numcalls.corr, comma, N0 is equal to true will give you the color coding as well as correlation values. And accordingly, you will make decisions. Next week also we'll work on some data where we'll do pre-processing everything. Same process will be repeated again and again. But remember, for regression problems, multicollinearity must be checked. In interviews, this is a compulsory question. What is multicollinearity? What is its problem? It creates overfitting, right? Too good to be true models greater than 0.95 R square. Go to data tab, data analysis. In data analysis, if you scroll down, you will see regression. Data analysis, okay? Click OK. You will get the window. Input Y range. Y range is what? Dependent variable. Click on the color box. Select the CNT column. Control Shift down arrow. Control Shift down arrow only once. Input Y range. Input Y range is CNT column. Input X range. All other columns. Temp, Shift side arrow, Shift side arrow. Control Shift. All other simultaneous columns as X range. Temp, humidity, wind speed and casual has to be selected as X variables. You can see the glowing sign, right? Tick mark labels in first row, tick mark confidence level, tick mark residuals, tick mark labels, tick marks confidence level, let it be new worksheet ply, tick mark residuals. Click OK. Click OK. You will get a data sheet, output sheet like this. Got it, all of you? First, box my input by range, CNT column, control shift down arrow, color box X range, success price temp, shift side arrow, control shift side arrow, control shift down arrow, labels stick change, residuals in the output. So this is the statistical output which we don't get in Python. In Python, we'll get only, in Python, we will get this R square. So what is the problem here? Range of, what is the range? So what is the problem? Underfitting. So what is the interpretation here? 58.05% dependent variable CNT is explained or the independent. What is the interpretation of this 0.5805? 58 point multiplied by 100, it becomes 58.05%. Only 58.5% variance in dependent variable is explained. Rest of the 42% is not explained by this model. Only 58% change that is caused in the dependent variable is explained by this model. Rest of the 42% is not explained by this. The amount of variance occurring in dependent variable caused by the model. That is what R square is all about. In this case, 58% variance or 58% change that is occurring in the variable called CNT is explained by the model or independent variables. Rest of the 42% is unexplained by this model. This model does not explain the rest of the 42%. Only 58% change is explained by this model. In statistical analysis, adjusted R square, in statistical analysis, we don't consider R square. We consider adjusted R square as it is to independent variables. So when you are looking at a statistical interpretation, we will not take into consideration R square. We will take into considering adjusted R square, sensitive to independent variable significance. But we won't get this in Python. We will get it in R software. We'll get it in Excel, but we don't get it in Python. In Python, we will only get R square. So I'll write it here in Python. But when you're looking at statistical analysis in R software or SPSS software or Excel or SAS, these are statistical softwares. Their adjusted R square is considered as the metric, not the R square. Because adjusted R square is sensitive to variable importance. If variable is important, adjusted R square will go up. If variable is not important, adjusted R square will. So that is the reason why adjusted R square is taken into consideration. Now, in statistical analysis, one more thing is important. Significance F, also called as, must be less than 0.05. Now, we won't get this value in Python, but in statistical analysis, you will get it. Significance F or model P value must be less than 0.05. Is it less than 0.05? It is E minus. So the null is coefficients equal to 0. Coefficients are not equal to, so we are rejecting the null. What are the coefficients? You can see here. Intercept, beta naught, beta 1, beta 2, beta 3, and see, these are the intercept coefficients. Are any of these coefficients 0? They are not 0. So, null hypothesis is rejected. Reject null. That coefficients are equal to 0. And you can see none of the coefficients are equal to, here only you can see, right, coefficients. This we won't get it in Python, but you will get it in statistical softwares. These are the coefficients, beta 1, beta 2, beta 3, beta. So the second metric we study is significance F for model p-value. We don't get this in Python, but in statistical analysis, we will be doing this to reject the null hypothesis that coefficients are equal to 0. You can see the coefficients. None of the coefficients are equal to. The third one in statistical analysis, again, which we don't get in Python, is independent variables p-value less than 0.05. So all the independent variables p-values are less than 0.05. Null is independent variable insignificant. Alternate is independent variable. So again, we have to reject the null here. We are rejecting the null, right? Because all the p-values are less. That means independent variables are significant. They are important. They are significant. See, in whole of Python, we don't get p-values. In whole of sklearn machine learning, we don't get p-values. sklearn machine learning, we don't get p-values. But when you run the same model, in terms of R or any other statistical software, you will get p-values. So in statistical analysis, adjusted R square first. In statistical analysis, see, there are two types of interpretation you will be generally doing. In Python, only coefficients. Whereas, if you look at statistical outputs, Excel, yes, statistical output, MS Excel, 0.60 to 0.95 must be. So, model p-value will be, or significance F in Excel, independent p-value must be. So the whole purpose of multiple linear regression, as I told you, is the equation. The whole purpose is equation, right? What is the equation? C and T is equal to 88.82, the intercept, 4180.90 into minus 2078.67 minus 3479.86 into wind speed plus 1.19. This is the regression equation. Intercept plus beta 1 into x1 minus beta 2 into x2 minus beta 3 into x3 plus beta 4 into x4. The mathematical symbol is valid. 3388.82 intercept beta naught plus beta 1 4180.90 into temp minus 2078.67 into humidity minus 3479 into wind speed plus 1.193 into casual. This is the equation which is created, which will be used for, this is the output. The output of a multiple linear regression algorithm is the equation which looks like C and T is equal to intercept plus beta 1 x1 minus beta 2 x2 minus beta 3 x3 plus beta 4 x coefficients into variable. Coefficients into variable. So from these coefficients, we create the equation. And using the equation, we'll calculate the predicted value. So how do we calculate? If I go to the previous sheet, I'll copy the first observation, Control C, I'll paste it here. This is the first row of our observation. First row observation is this. These are the actual value. First row. So is equal to 3388, 4180, the actual value of temperature, coefficient of humidity multiplied by actual value of humidity, plus coefficient of wind speed multiplied by actual value of wind speed, coefficient of casual multiplied by actual value of the coefficient and intercept multiplied by the actual values 29894603. See this value and this value. So using this formula is there, na? It will calculate for all the observations. For all the 730 observations are there, na? It will calculate the predicted values for all the 731. So this is the first row. This is the first row. Now, if I replace there with, let us say, second row, see 2753, this. So it will calculate for all, like using the same formula, it will calculate for all. And then it will also calculate residual. What is residual? Actually, the data says 985. The predicted is 2989. So what is residual? Is equal to actual minus this and this are predicted. This is the residual. So as part of the process, using these coefficients and the actual data, it will calculate predicted values for all the observations. See, if you go down, you will see predicted for all 730 and also the residuals for, because in original data we have Y, right? Original data we have CNT. CNT minus predicted CNT, you will get the residuals. So this is the process. It follows this process and calculates for every observation a predicted value. From predicted value, residual is calculated, and using residuals, R square is calculated, adjusted R square is calculated, your P values, this standard errors, T stat, P value, all these things are calculated using. So the fundamental is, got it? So don't worry, you may not understand now. I'll repeat the concept again in the next class, then you will understand. Because these are complex algorithms. You won't understand it in one single attempt, most of you. So we will repeat it. Okay. And we will, whenever we discuss this, whenever we run the model, I'll explain the algorithm. So this is a fundamental algorithm which you must by heart. This is a compulsory questions you will get in multiple linear. This is the base algorithm. This is the base algorithm. You will definitely get questions in MLR. Like what is residual, what is multicollinearity, what is the regression equation, how will you use the regression equation. So all these things will be there in regression. So these important concepts you must remember. Okay. So using the equation, it will calculate the predicted values. And from predicted values, residuals will be. So let's go back to the Python notebook. Bike share data. Bike data dot. All of you ran the bike data notebook. All of you opened and ran all the cells. Bicycle share data. Can we proceed? So we have to split the data. Num calls is equal to bike data double square bracket from temp to CNT. These are numeric calls. Temp to CNT, they are numeric calls. Object calls is equal to bike data double square bracket season to weather situation are categorical calls. Temp to CNT are numeric calls. Season to weather situation are categorical calls or object calls. So our first step is split data into numeric and non-numeric. So what should we do on object calls? What should we do on object calls? Encoding. Yes. Label encoding, or let us do get dummies, right? Object calls underscore dummies. Yeah, it will take time to come to this thing. You are in the first thing, na? Object calls, comma, columns is equal to, you can copy the columns from season to weather situation. 32 variables it created. And how many numeric calls we have? 1, 2, 3, 4. Okay, we'll 1, 2, 3. 36 into 20 is how many? 720. What is the rule? 20 observations per. So already we have object variables 32. Because of dummy variable encoding, we got 32. Right? And we'll have 4 numeric variables. If you remove the multicollinearity variables, we'll have 4 variables. 36 into 20, 720. We have how many observations? 731. So data sample is enough. So always check the data sample. For regression, 20 observations per one column. We have 32 columns plus 4 numeric columns, 36 columns. 36 into 20, 720. But we have 731. So we have sample size greater than required. Suppose if sample size is not enough, then what we do? We don't use get dummies. We use label encoding. Then label encoding means how many columns? 1, 2, 3, 4, 5, 6, 7 columns only will be there. Because label encoding will do it in the same column, right? So then it will be, we will have only 7 columns object and 4 numeric. 11 only we will have. But we have data, so we are doing get dummies. Got it? Important observations from now onwards you have to make whether the sample size is enough or not. If sample size is not enough, your model will fail. Numcalls.corr. So what I am checking here, what we are checking here, we are checking for multicollinearity. All right, all of you got dummies. What are you getting? Unhashable dimensions means columns is equal to you have given the same backdated double square bracket you have given for subsetting double square bracket, no? One for the list, one for the subsetting. So multicollinearity is there, right? You can see here 0.99 and 0.95. From numcalls, we have to delete two variables. Copy the numcalls. We'll remove atem and we'll also remove. So these are our new numcalls. Now, in our original model, we have built only with numeric calls. In Excel, we will do that only. Y is equal to numcalls.cnt. X is equal to dot draw, comma, axis is equal to 1. See, in Excel, we have used only these variables, right? In Excel, we have only used these variables. So I am just building a basic model with the one which you have done in Excel. Later, I will build with all the variables, with obj calls and all those things. Because we have not used the object data in Excel. To check whether our Excel output and this matches, we are just doing a model. From sklearn.linear_model regression. Reg is equal to linear regression null brackets. Reg model is equal to reg.fit x comma reg model dot x comma must be between 0.60 till 0.95. So we got exactly same value in reg model dot intercept. See 38,388.82. Intercept is also exactly print x dot columns reg model dot coefficients. See, coefficients also exactly same exact values what we got in for both the intercept and the coefficients. What happened? You missed something? So exactly same values we get in what we get in Excel, but we don't get the p values. Reg predict is equal to reg model. See, 2989, 257, 2753, 2580, same values what we got in Excel we got here. See, 29894603. Same thing what we got in exactly to the decimal. We got the same values what we got in Excel. Reg recit is equal to y minus reg recit. You will get the same residuals minus 2004.406. You will get the values. Same values what we got in Excel. Got it? See, whatever the software, these are the basic values you should get. Whatever you get the software, these are the values you must get. This is the fundamental calculus. So whether it is R or Python or SAS or SPSS, you get the same. So like what we compare here, to the decimal, same values you get. To the decimal, you will get the same. This is the process of regression. This is the process of. And one last thing we have to calculate is the RMSE. np.sqrt. np.mean star 2. We got the also called as RMSE, diagnostic for all regression problems.